Hi, Assalamualaikum and good day. Today we are going to learn on how to solve problems involving the application on first order ODE. This is the objective of our lesson. Hopefully, by the end of this session, you are able to solve problems that involve growth and decay problems, temperature problems, chemical mixture problems, and RC and RL circuit problems. Let's start with growth and decay problems. Before you solve the problems, you need to derive the formula first. Let NT be the amount of population and dN over dt is the time rate of change. If dN over dt is proportional to n, then we can represent it as dN over dt equal to Kn. Separate the variable, become dN over n equal to k dt. Integrate both sides, you will get ln n equal to kt plus c. Exponent both sides, you will get n equal to exponent kt plus c, which can be simplified to c exponent kt, in which c here is the initial amount of population and k here is the constant. If k is greater than 0 or positive value, then this is what we call as growth problem. But if k is less than 0 or negative, this is a decay problem. Therefore, the formula to solve the growth and decay problem is Nt equal to c exponent kt. Now, let's refer to example 17. The population of a certain country is known increase at a rate proportional to the number of people presently living in the country. If after 3 years the population has doubled, and after 5 years the population is 23,000, estimate the number of people initially living in the country. As this is referred to the growth problem, the k value that you will obtain must be a positive value. First of all, you need to derive the formula by solving the equation of dN over dt equal to Kn. Separate the variable, you will get dN over n equal to k dt. Integrate both sides, you will obtain ln n equal to kt plus c. Exponent both sides, you will get n equal to exponent kt plus c. By using the power rule, the one on the right can be represented as exponent kt multiplied with exponent c. As exponent c is a constant, we can represent this using another symbol, for example, capital C. You can also use other symbol, for example, A and so on. Therefore, the formula for the growth and decay problem is given by Nt equal to c exponent kt. Next, put all the given information in the following table. The first column is referred to the t, which is in years. The second column is referred to the Nt, and the last column is referred to the formula c exponent kt. Always start with t0. When t is 0, then you will get n0, which is equal to c. And after 3 years, meaning when t is 3, the population has doubled, so meaning it should be represented as 2n0 equal to c exponent 3k. And after 5 years, the population is 23,000. So when you substitute into the formula, you will get c exponent 5k. From the table, you will get n0 equal to c and 2n0 equal to c exponent 3k. By solving these two simultaneous equations and simplify, you will get k equal to 1 over 3 ln 2. Substitute this k value into the formula of n, you will get nt equal to c exponent of 1 over 3 ln 2 multiplied with t. Take note, as this is referred to growth problem, the k value is positive. Next, substitute t with 5 and n with 23,000 into the formula and simplify. You should get c equal to 7244.546. As c here is referred to the number of people, it should be represented using the whole number, that is just by ignoring the number after the point. Therefore, the number of people initially living in the country is 7244. Let's proceed with example 18. A bacteria culture is known to grow at a rate proportional to the amount present. After 1 hour, 1,000 strains of the bacteria are observed in the culture, and after 4 hours, there are 3,000 strains of bacteria. Find an expression for the approximate number of strains of the bacteria present in the culture at any time t, and the approximate number of strain of the bacteria originally in the culture. As this is referred to a growth problem, the k value that you should obtain must be positive value. First of all, you need to derive the formula by solving the equation of dn over dt equal to kn. Separate the variable, you will get dn over n equal to k dt. Integrate both sides, you will obtain ln n equal to kt plus c. Exponent both sides, you will get n equal to exponent kt plus c. By using the power rule, the one on the right can be represented as exponent kt multiplied with exponent c. As exponent c is a constant, we can represent this using another symbol, for example, capital C. You can also use other symbol, for example, A, and so on. Therefore, the formula for the growth and decay problem is given by nt equal to c exponent kt. Next, put the information into the following table. The first column is referred to t in hours, the second column is nt, and the third column is the formula c exponent kt. When t is 0 and naught is equal to c, after 1 hour, which is when t is 1, the nt is 1000, which is equal to c exponent 1k. And after 4 hours, the nt is 3000, which is equal to c exponent 4k. From the table, you will get n naught equal to c, 1000 equal to c exponent k, and 3000 equal to c exponent 4k. By solving the equation 2 and 3 and simplify, you should get k equal to 1 over 3 ln 3, which is referred to a positive value. Substitute the k value into the second equation and simplify. You should obtain c equal to 693.3613. Therefore, the approximate number of strains of the bacteria present in the culture at any time t is represented as nt equal to 693.3613 exponent of 1 over 3 ln 2 multiplied with t, and the approximate number of strains of the bacteria originally in the culture is 693.